Sorry. Okay, so please go through the folder, the Unit 12 gases folder, and then, then when you open up today's, basically what you're going to see is you got this, okay? And the reason I wanted you to go through the folder is because I need you to memorize this box. I need you to love this box, and I need this box to just ingrain itself in your head because I need you to picture this box every single question that you are going to be answering in this chapter, all right? We are kind of trying to decide if we're going to make you guys as pre-AP do a little bit more of the calculation stuff, but for the most part, we're going to be asking you guys to be able to do proportional reasoning, which means if I do this, does this increase or decrease? If I increase this one, does it increase or decrease? If I decrease it, what's it going to do, right? And so I need you to focus on this box. And so what I want us to focus on in this box is, let's make the observations real quick. In this box, there is a size to the box, right? So it is this big, okay? One of the things that we can mess with is we can expand the box out, or we can compress the box in, right? So we're going to be messing with the size of the box. Another thing that you notice is you have little blue and red particles. They're just kind of moving around. They are moving, and if you actually focus in on one of them and watch only one particle move, you'll notice none of them do a curvy thing. None of them go in a little loopity-loop. They're all straight lines. Every movement that it does, okay? So these things are in constant motion. If you notice, none of them have stopped moving since, right? I know this is a computer simulation, but it really is showing you what they're actually doing, your gas particles, okay? So they're in constant motion. You also see that they're kind of slow at sometimes, fast at other times, and whatever. And so we can take that whole average, and we can talk about what's going to happen if we warm this thing up. What if we increase the kinetic energy? Things should start moving faster. If we slow down that kinetic energy, things should slow down, okay? So you're picturing that box. You also see that all these particles are hitting the sides of the container, okay? The collisions are going to be important. What happens when we have a smaller box to those collisions? What happens if we have a bigger box, more space, okay? So get to love this box. That's what I recommend. Oh, I guess I should have added the one more variable is, what if I add more dots in there? What if I take dots away? So those 4 things that I kind of made you observe in this box, I want you to remember it, okay? We have a simulation that we'll be able to use today, and that way you can also refer to this to help you with that. So I'll kind of go where, or I'll let you know where I want you guys to click for that. Oh, that's not going to go away. That's cool. All right, that's okay. Anyway, so if you scroll down, we see kinetic molecular theory. We're going to deal with that one a little bit more tomorrow, I think. It's towards the end of the assignment. I might pull it back up, but for today, I want us to really just focus on what are those variables, okay? But kinetic molecular theory is what all of the gas laws and everything that we're going to be studying is about, right? So it's about kinetic movement. Those things are moving. Molecular, particles, right? It can be molecules, can be little atoms, whatever. We reduce them down to the size of a particle, okay? And then theory, meaning that it is a tested thing, right? And so we can rely on this theory to predict how things are going to act. All right. Okay, so then you have this. Just know these are never buttons. We don't embed the buttons. So we did get a couple emails saying, "Hey, the button doesn't work." Yeah, it's not a button. It's just a picture. So you actually have to click through this, which will open up to a little K-12 reading thing. Okay, and so I do recommend that you take a second to look through these because you're going to need these 5 postulates. You might get to it today, or you might get to it tomorrow. All right. Our goal today is make sure you get through questions 1 through 4 on the assignment, and then tomorrow you can finish it, okay? So these are the 5 postulates. So if you do get to that question in the assignment, that's where you're going to be looking, okay? So it's the fact that you have little tiny particles. We already saw that, okay? It's the fact that we have, they're in constant motion, and they are straight lines. Then you have that they are going to be hitting the container walls. Okay, and they're doing it in elastic collisions, meaning they're not going to slow down just because they hit the wall. It's not going to be like so significant that it's just going to like stop, right? So that's what the elastic collision is talking about. And then we had the no forces of attraction or repulsion. That's why we don't see any loopity-loopities, right? So they're not repelling each other. They're not attracting each other to stick together. And then finally, temperature is going to be defining how fast things are going. how much they're moving. You can use this video. I gave you guys a boring one in the actual question, so you might come back and use this one instead, okay? Then it goes through the 5 postulates. But we will deal with that tomorrow. So let's go ahead and open up the assignment. I want to see if yours got rearranged. I tried rearranging it, but I don't know if it did. Let me see. It did not. Okay, so what I recommend is you should start with, start with 1, obviously, then go to 3 and 4, and then come back to 2. So I should have, so if you hadn't opened it, there we go. Now it's all moved around. Okay, so your goal is to get through the first 4 questions today, and then we can deal with 5, 6, and 7 tomorrow. Okay, so we're going to go ahead and go to that. This is our scenario that we're doing. All right, so remember that little box, but also imagine buying a balloon bouquet at a party store. What's going to happen when you carry it out on a hot summer day? What's going to happen if you carry it outside on a cold winter day or a snowstorm that like happened? All right. What happens to the balloons if they're made of latex, which are the ones that we can blow into and they get bigger, right? Versus something like a mylar balloon, which are the ones that look like foil. So the ones that you usually buy that are on the stick, right? Which can't stretch. What happens if I add a little bit of gas versus a lot of gas? Those are the factors that we are talking about. These are going to be the 4 variables that we're going to focus on today: volume, pressure, temperature, and moles of gas. Okay? So V, P, T, and N. This flashcards link does not work yet unless you have a mouse and you can right-click it and open it in a new tab. If you try to open it in here, it won't work. Sorry, I messed up on that. So I will probably make that available tomorrow on your guys' little page. Okay, so your first question that you're dealing with is you are reminding yourself about states of matter. Okay, so you're going to remind yourself of your different properties of your states of matter. So all that I'm going to do is we're not going to watch this, but I'm going to show you where you want to fast forward your screen to so that you have the information that you need. There we go. 239. 239 is a good image that you can look at. Okay, so I want to talk about this image for a second. So what we see, solids are rigid, meaning they have that fixed shape. They stay together, right? But are they moving? Who remembers? Anybody remember? Do solids actually move? Yes, they vibrate. They're sitting there wiggling, all right? So these guys, yes, good job. Nice job, Shelby. All right, so they are vibrating. All right, only at absolute 0, which gets mentioned in today's assignment, but you'll see it a little bit further in this chapter. But absolute 0 is where everything stops, and we've gotten really, 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 really close to it, but we've never really actually hit the part where we can make all matter, particles, everything absolutely stop. Okay, so yes, everything is actually moving. You're going to need that for one of your questions. But anyway, solids are rigid. They have fixed shape, fixed volume. So definite shape, definite volume, can't be squashed. They are not compressible. Your liquids, they are not rigid, meaning they can flow through each other. Okay, so once again, not rigid means they're fluid. Fluid, so liquids and gases are fluid. Not a fixed shape, but they do have a fixed volume. If I start with 5 cups of water and I pour it into another container, it's still 5 cups of water. And then these are also not compressible. Gas is going to be not rigid. That's obvious. They're like flowing through each other, like running around like crazy. No fixed shape, right? Yeah, so it fills its container. No fixed volume. Because it expands to whatever container, you don't really have that set volume, okay, of the gas particles because they don't stay together. And then finally, this one is the only one that is compressible, because of all this space that is in between them. Okay? So that should have been, if you were following along on the little questions, you should be able to answer these with no problem. Which ones were compressible? So again, 239 is a good place to pause. 239. And then, so compressible, definite shape, fluid, composed of atoms in motion, all of them, and definite volume. Okay, so let's skip over to number 3. Okay, so for number 3, you have this little simulation. If you'd like it a little bit bigger, or if you want to keep it so that you can kind of refer to it along the way, click on the link. I really do recommend you just have it open in another tab, okay? You're going to be using Ideal every single time. Sorry, I guess I should walk you through what happens when you push on the link. There you go. So when you push on the link, it's going to take you just to this. Just push the play button, and it should work, okay? If it doesn't, then use the one that's in the actual question. All right, so you're going to push on Ideal. So I just want to point out what different buttons you have here, and that way you can use this on your assignment today and tomorrow, okay? So the first thing I want to point out is here's our box. Here's our set box. This handle squishes it. This handle expands it. So we can now mess with the size of the box, right? Volume. You also have this option to open this up. We're not going to use this one today at all, but I just wanted to let you know that you're able to let out all of your gas molecules. Then you see that you have a thermometer. Thermometer measures temperature. So we have Kelvin and Celsius, okay? Kelvin and Celsius. There's the question on number 2 is asking about that. Question number 3, I should not say question number 3, I'm sorry. For you guys, question number 3 was Kelvin. Question number 4 was the pressure, ATM and kPa, okay? All right, so you have a pressure gauge, we have a thermometer. Then if you take this little bicycle pump and you add some gas molecules into it, you see those molecules start doing basically what we saw in that first box that I told you. Memorize it, use it, okay? You're still going to want to do that. So use the simulation to kind of help with things in this chapter, okay? So you see that? We can now squish them all together. So we made the box smaller, and you can see how that affected things. You can see that these numbers are changing, right? If we were to add more in there, we have more of the little spheres. You can pause it. There's your particulate diagram, okay? You can expand this back out, give it more space. Sorry. And then, yeah, and then we can take this, we can say heat this up, and we can watch what those particles do. Okay, so hopefully you're seeing that the temperature is definitely changing, right? You also should notice and observe that all those particles just sped up. Then if you cool it down, they're going to slow back down, and you see that that temperature up here is changing, okay? So again, you have those options. Then you also have, for tomorrow, you have this option, hold something constant. So there'll be a question that you can use this simulation for sure, okay? And then finally you have this. This is counting up your particles. So if I pump more particles in there, that number is now changing. Okay, and then you can always come down here and reset it. All right, so you have all of those options to use. So I would have the simulation open to help. These questions are pretty straightforward, so I'm going to let you guys handle those. So number 3 says, look at the pressure, shows that, what are the 3 letters? So you're going to type those in, If you look at number 4, I just rearranged mine. I'm so sorry. This is your guys' number 3. I should change this back. That's okay. All right, so with this one, you're basically going to look at what happened to those temperatures, what happened with the Celsius. You're going to look at both of those, okay? So you have that. Then go back to number 2, all right? So I want you to do number 2 after you've kind of looked at that simulation a little bit, all right? Number 2 is now going to force you to look through each of these little variables. So for example, we have, so everything in red is the new variable, all right? So everything in red is the new variable. You have volume, you have pressure, we have temperature, we have moles, okay? So answer these questions. They're all drop downs. I tried to keep the answer choices as simple as possible, so just, you know, use a little common sense with it, but read through it, all right? I don't leave you hanging on any of your calculations, okay? You do have the capability to highlight things, so when you're reading this, highlight the definition, right? So the definition of temperature is the average kinetic energy of the particles. Have it highlighted so that you can go back up to that and look at it, okay? And then down here, this will be your last little test. This is what we'll start with tomorrow, okay? So again, on yours, please start with 3, 4, and then go back to 2. Just do the first 4 for today and do the other ones tomorrow. If you choose to work ahead, that's fine. You can come back with questions tomorrow, okay? So people at home, I will see you guys later. Get your stuff done. Let me know if you need any help. Use the simulation. It is super friendly, I promise. Try it out. Explore. Science. All right. See you guys later. Bye. That was a really lame ending to that Zoom call.